Just think about the sheer amount of data flying around every single second. It's not just big, it's genuinely astronomical.
Yeah.
Every click, every purchase, every sensor ping, every single message. And look, for businesses today, you just can't afford to drown in it. They
No.
have to harness it, understand it, act on it. I mean, that's the engine for growth now, isn't it? It's how you stay competitive. But honestly, managing that scale and the speed, it feels pretty overwhelming just thinking about it.
It really does.
Welcome to the deep dive. We take these huge, complex topics and try to boil them down to what you really need to know. Today, we're diving deep, really deep, into modern data engineering, and specifically this foundational idea powering it, the modern data stack as it looks in 2025.
Yeah, it's a critical area.
We've gathered insights from, well, a whole stack of articles and research papers. They really lay out the landscape, the trends, the challenges, the opportunities. Our mission today, let's try to cut through all that complexity. We want to pull out the most important insights for you and figure out what this rapidly changing field actually means in practice.
And astronomical is definitely the right word for the data volume. Some of the sources point to an IDC projection. They reckon global data creation will hit something like 175 zettabytes by 2025.
Wow, 175 zettabytes. It's hard to even wrap your head around that number.
Exactly. And it immediately shows why the old ways of handling data, well, they don't work anymore. They weren't built for this.
So traditional approaches, you mean?
Yeah. Data engineering used to be, much more static,
Mhm.
often tied to physical servers, on-premises systems, using those classic ETL processes.
Extract, transform, load.
Right. You'd pull the data, spend ages cleaning and reshaping it before you even loaded it into your data warehouse. It's a real bottleneck. Fine for smaller, slower data maybe, but not for today. So the modern approach, it's completely different. It's all about flexibility, leveraging the cloud. It's often event-driven.
Mhm.
And crucially, it mostly flips ETL on its head, uses ELT.
Extract, load, transform. So load first.
Precisely. The big idea is get the raw, messy data loaded first into cheap, powerful cloud storage, like a data lake or a modern data warehouse. Then you use the power of that cloud environment to do the transformation work inside the warehouse.
Ah, okay. So you transform it after it's landed.
Exactly.
Yeah.
And that lets you transform the same raw data in lots of different ways for different analyses without having to go back and re-ingest everything. Much more flexible.
Okay, right. I get the mechanics. But why this big shift? You mentioned cloud power and speed, but what else is really driving organizations away from traditional ETL towards this modern ELT thing?
Well, it's really a few things coming together. Like you said, the economics of the cloud just changed the game. Storage got incredibly cheap, and compute power became instantly scalable on demand. So suddenly loading terabytes or petabytes of raw data wasn't just possible, it was actually cost-effective.
Right.
But it's also driven by business needs.
Mm.
There's this accelerating demand for real-time insights. Businesses need to react now, not hours or days later. Traditional batch ETL just couldn't deliver that speed.
Makes sense. The pace of business is just faster.
It is. And companies also need that agility, the ability to scale their data systems up or down quickly. On-prem systems make that really hard, sometimes impossible.
Mm-hmm.
The modern cloud approach gives you that elasticity. So yeah, it's cost, it's speed, it's scalability, and it's about enabling those bigger digital transformation goals.
So the whole foundation is shifting. Given that, what are the really big trends, the key movements shaping data engineering specifically right now in 2025?
Okay, yeah. One of the most exciting trends is how AI is getting woven into the fabric of data engineering itself.
Hmm.
Not just using the data for AI, but AI helping the data engineer.
Okay, how so? AI helping build pipelines.
Sort of, yeah. We're seeing these AI-driven data solutions where machine learning is integrated right into the engineering workflows. So think about AI assisting with figuring out data schemas automatically, or detecting and maybe even fixing errors in data pipelines. Some sources even mention AI helping generate pipeline code.
Wow, like a co-pilot for the data engineer.
Exactly. That's a great way to put it. It promises a lot more automation, more efficient workflows,
Right.
freeing up engineers from some of the tedious stuff to focus on more strategic problems.
Okay, that's big. What else?
Well, another huge force is that expectation for real-time data processing. It's just becoming standard in many areas, like
Finance or e-commerce.
definitely finance, healthcare, understanding customer behavior online as it happens. For those time-sensitive decisions, you need instant insights.
And the tech for that.
Technologies like Apache Kafka, Apache Flink, these high-throughput streaming platforms are crucial. They're built specifically to handle these continuous flows of data with really low latency, so businesses can react almost instantaneously.
Got it. Real time is key.
Yeah. And underpinning a lot of this, naturally, is the massive shift towards cloud-native platforms, or sometimes hybrid setups.
Cloud first seems to be the mantra everywhere.
It really is. The preference is overwhelmingly for cloud platforms, AWS, Google Cloud, Azure, because they offer that built-in scalability and flexibility we talked about. They have suites of tools like AWS Glue, Google Cloud Dataflow, Azure Data Factory, and then you have the big cloud data warehouses, Snowflake, BigQuery, Azure Synapse, Databricks. They're really central to this whole thing.
So most companies are heading that way.
Sources suggest, yeah, a big majority, like maybe 85% of enterprises, will have a cloud-first strategy by 2025. And data engineering is right at the heart of making that happen. Hybrid setups still exist, of course, balancing older systems with new cloud power.
Okay. Cloud, AI, real time. What else is top of mind?
Well, something that's always critical, but perhaps getting even more focus, is data quality, governance, and observability.
Making sure the data is actually trustworthy.
Absolutely fundamental. Everyone knows bad data leads to bad analytics, bad decisions. It's worse than having no data sometimes.
Right. Garbage in, garbage out.
Exactly. So this means really robust processes for data validation, cleansing, clear governance frameworks who can access what data, how is it managed, ensuring you meet regulations like GDPR or CCPA.
And observability. What's that specifically?
Observability is about having deep visibility into your data pipelines, monitoring the data flow, checking the accuracy in real time, automatically detecting anomalies or issues, and being able to trace the data's journey, its lineage. It's crucial for trust and troubleshooting.
Makes sense. You need to know what's happening under the hood.
You do. And one final big trend is this drive towards data democratization and self-service analytics.
So getting data into the hands of more people, not just the tech teams.
Precisely. Breaking down those traditional silos, empowering business teams, marketing, sales, product to access and analyze data themselves.
How's that happening?
Through these self-service analytics platforms. Tools like Tableau, Power BI, Looker. They have intuitive interfaces, visualization capabilities. They let users explore data and get answers without needing to write complex SQL or constantly rely on the central data team for every little request.
Okay, so putting it all together, it sounds like the goal is faster, smarter, more accessible, and more reliable data across the board.
That's a really good summary.
Yeah.
Data is becoming more pervasive, and the tools and processes are evolving to make it genuinely useful for everyone.
Right. So you mentioned the modern data stack is kind of the engine room for all this. What actually is that stack? What are the key pieces, the building blocks?
Yeah, the modern data stack, or MDS, it's not like one single product you buy off the shelf.
Okay.
It's more a combination of different software tools, processes, and strategies, usually cloud-based, designed to be integrated, scalable, and modular.
Modular meaning you can swap pieces in and out?
Exactly. That's a key difference from older monolithic systems.
Right.
It gives you flexibility, it's often lower maintenance, and even smaller teams can manage it effectively compared to the old big iron systems. The whole focus is enabling data-driven decisions and democratizing that access we talked about.
Okay, so let's break it down. What are the core functions, the jobs that need doing in this stack?
Right. Let's walk through the main areas. First up, you need data ingestion.
Getting the data in.
Exactly. Connecting to all your different sources databases, SaaS apps like Salesforce, website clicks, mobile app events, third-party data feeds, and pulling all that data into one central location.
And tools for that.
Popular ones are tools like Fivetran, Stitch, Skyvia. They often have hundreds of pre-built connectors, which really automates a lot of that painful integration work. And for the real-time stuff we mentioned, this is where streaming platforms like Kafka fit in, and techniques like CDC change data capture, which efficiently grab only the changes from source databases.
Okay, data's ingested. Where does it go?
That brings us to data storage. And the heart of the modern stack here is typically a cloud data warehouse.
Like Snowflake, BigQuery, Redshift.
Exactly, though. Snowflake, Google BigQuery, Amazon Redshift, Azure Synapse. They're designed to store and query massive amounts of structured and semi-structured data really efficiently in the cloud. We're also seeing the rise of the data lakehouse idea.
Lakehouse, like lake meets warehouse?
Kinda, yeah. It tries to blend the flexibility of a data lake storing raw, unstructured data cheaply with the performance, governance, and reliability features you get from a data warehouse. Databricks is a big proponent of this.
Interesting. Okay, so data stored, now what?
Now comes data transformation. This is where you do the actual work of cleaning the data, combining different sources, aggregating it, reshaping it,
Hmm.
basically getting it ready for analysis.
And this is the T in ELT happening after loading?
Precisely. It happens inside the powerful data warehouse or lakehouse environment. And a hugely popular tool for this transformation step is DBT Data Build Tool.
DBT, right. Heard a lot about that.
Yeah, it lets teams define transformations, mostly using SQL, but manage it like software code with version control, testing, documentation, dependency management. It brings engineering discipline to the transformation process. Skyvia also offers transformation capabilities.
Okay, so we ingest, store, transform. How do you manage all these steps? Make sure they run in the right order on time.
That's where data orchestration comes in. Think of it like the conductor of the orchestra or air traffic control for your data pipelines.
Making sure everything flows smoothly.
Right. It automates the scheduling, execution, and monitoring of all these different tasks. Ingest this, then transform that, then run this check. Apache Airflow is a very common open source tool here, but there are others like Prefect and Dagster gaining traction too.
Okay, now the data's ready. How do people actually use it?
That leads us to business intelligence BI tools. These are the platforms that let users actually visualize the data, build dashboards, explore it interactively, and get insights.
So Tableau, Power BI, Looker again.
Exactly. Those are the big players. They bridge the gap between the clean data in the warehouse and the business user who needs to understand it without needing deep technical skills.
And for the really advanced stuff, machine learning.
Yep, there's a layer for data science. This involves tools and platforms for building ML models, doing complex statistical analysis, forecasting, often using tools like Apache Spark, perhaps integrated with platforms like Jupyter Notebooks or specialized tools like SAS.
Got it. That seems like a fairly complete flow. Data in, processed, analyzed.
Almost. There's one more piece that's become really important, representing a newer capability, reverse ETL.
Reverse ETL. So sending data back out.
Exactly. Instead of the data journey ending in the warehouse for analysis, reverse ETL takes the cleaned, processed, insights-rich data from the warehouse and pushes it back out into the operational tools that business teams use every day.
Like sending customer segments back to the CRM or product usage data to a marketing tool.
Precisely. Sending insights back to Salesforce, HubSpot, Marketo, Zendesk, you name it. Tools like Census, HighTouch, Polytomic, Weld focus on this.
Why is that so important?
Because it closes the loop. The cleaned, valuable data in your warehouse doesn't just sit there for analysts. It gets pushed back into the hands of operational teams where they work so they can actually act on those insights directly. It makes the data truly operational.
Ah, that makes a lot of sense. Closing the loop from insight to action.
Right. And then, woven throughout all of this, as we mentioned in the trends, are the data quality and governance tools. Things like Allocation for cataloging or Great Expectations for validation. They aren't really a separate step, but essential components ensuring trust, accuracy, and compliance across the entire stack.
Wow, okay. That is quite a comprehensive picture. A lot of moving parts that need to work together seamlessly.
It is.
It sounds incredibly powerful, but I can also see how it could get complex. So what are the big payoffs? Why go through the effort of putting this modern stack together? What are the main benefits?
The benefits are pretty significant, and they touch on core business strategy. First off, huge scalability and flexibility.
Because it's cloud-based and modular, right?
Exactly. You can spin up more compute power when you need it for big jobs, then spin it down. Scale stores almost infinitely. And that modularity means you can swap out, say, your ingestion tool for a better one later without ripping everything else out. You're not locked into one vendor's ecosystem entirely.
Right. Flexibility is key. What else?
Often, optimize costs. Moving from owning and maintaining expensive on-prem hardware to cloud services can save a lot. Plus, many cloud tools use consumption-based pricing. You pay for what you use. Serverless options minimize idle costs. And the automation built into the stack reduces manual effort and labor costs. It lowers the barrier to entry, too.
Good point. Makes it more accessible.
Then there's faster decision-making, that real-time processing capability we talked about. It means businesses can get insights from live data and react much, much faster than waiting for overnight batch jobs, reducing that latency in business response.
So real speed benefits there.
Definitely. And because these tools are mostly designed to work together in the cloud, you get enhanced analytics and efficiency. Data pros can get data processed faster with fewer errors from manually moving things around. You also get genuinely improved data quality and trust. The integrated tools for validation, testing, and governance help ensure the data is reliable. And that's absolutely critical if you want to feed it into AI models and trust the predictions.
Right. Can't build AI on shaky foundations.
No way. And then there's the democratized data access and culture. Those user-friendly BI tools and the self-service approach mean more people across the company can actually use data confidently. It helps foster that data-driven culture everyone talks about.
Breaking down the data priesthood, so to speak.
Sort of, yeah. And maybe most strategically, this modern stack provides the robust, scalable, high-quality data backbone needed to power advanced AI and ML initiatives. AI needs tons of clean data, and the MDS is purpose-built to deliver exactly that.
Okay, that's a really compelling set of advantages, strategic stuff. But nothing this powerful comes without challenges, right? What are the main hurdles, the obstacles organizations hit when they try to implement or manage this in 2025?
Oh, absolutely. It's definitely not a walk in the park. One of the biggest challenges is simply taming the complexity.
Just the sheer number of tools and data sources.
Yeah, the volume, variety, and velocity of data just keep increasing. Designing pipelines that are robust, scalable, and reliable across all these different sources is genuinely hard engineering work. And then just managing that whole ecosystem of tools we described, making sure they're integrated properly, monitoring them, keeping them updated, that can be a significant operational burden. It can become quite sprawling.
I can see that. What else?
A really persistent one is the talent shortage. Finding skilled data engineers who really understand these modern cloud tools, the architectural patterns, ELT, DBT, orchestration. It's tough.
Demand is high.
Hugely high. Sources pointed out that data engineer was like a top 10 most in-demand tech role just recently. The demand just keeps outstripping the supply. So companies either have to invest heavily in training their own people or find good external partners, which can be costly.
Yeah, that's a big bottleneck.
It really is. Then data security and privacy, always critical, but maybe even more complex now.
Because data is flowing everywhere, in the cloud, in real time.
Right. Securing that data across multiple cloud services, ensuring compliance, it's a constant battle. Cyber threats evolve constantly. You need strong encryption, regular security audits, robust access controls, good lineage tracking to see who touched what data when, and navigating GDPR, CCPA, and other regulations adds another layer.
Definitely not trivial.
Not at all. Another common issue is integrating legacy systems. Lots of companies still have older databases, mainframes, or applications that weren't built for the cloud or modern data approaches.
So bridging the old and the new.
Exactly. Getting data out of those old systems reliably and integrating them into the new cloud stack can be really complex, technically challenging, but often unavoidable.
Okay. And what about cost? You mentioned optimized cost as a benefit, but is it also a challenge?
It can be, yeah. Cost management itself is the discipline. While the potential for savings is there, building and running sophisticated infrastructure, especially for real-time or massive scale, can get expensive if you're not careful.
Avoiding those surprise cloud bills.
Right. You need careful planning, monitoring, and optimization to balance performance with cost efficiency. This is an ongoing effort.
Okay, so real challenges around complexity, talent, security, legacy systems, and cost control. But clearly, organizations are tackling them because the benefits are there. Looking ahead then, where do things go next? What are the exciting opportunities on the horizon for data engineering?
Yeah, building on this modern foundation, there's a lot of potential. We'll definitely see continued leveraging of AML potential. Not just AI in the pipelines, but using the high-quality data from the pipelines for much more sophisticated predictive analytics, generative AI applications across the business.
Taking to the next level.
Exactly. Another area is the expansion of edge computing.
Processing data closer to where it's generated, like on devices.
Right. For things like IoT sensors, autonomous vehicles, factory equipment, processing data right there at the edge reduces latency, saves bandwidth. Data engineers will need to design architectures that manage that flow from the edge device back to the central cloud systems.
Interesting. Distributed data processing.
Yeah. We'll also see continued demand for advanced data visualization. As data gets more complex, we need even more intuitive ways for people to explore and understand it quickly. And an interesting newer opportunity is around sustainable data practices.
Green data engineering.
Kind of. Thinking about how to optimize data storage to use less space, reduce energy consumption in data centers, design more efficient processing algorithms, aligning data strategy with environmental goals. It's an emerging area.
That's really interesting. What about organizationally?
Organizationally, there's a big push towards more cross-functional collaboration and architectural patterns like the data mesh.
Data mesh. Heard that term too. How's that different?
It's less about technology and more about organizational structure and ownership. Instead of one central data team trying to serve everyone, Data mesh decentralizes data ownership.
So domain teams own their data, like the marketing team owns marketing data products.
Exactly. They treat data as a product they own and are responsible for, serving it up via standardized infrastructure and APIs for others to consume in a self-service way. The idea is to push data ownership and outcomes closer to the actual business domains and consumers. Sources mention Fifth Third Bank as an example using this approach.
Pushing autonomy outwards, okay.
And looking even further ahead, beyond 2025, expect even more automation.
AI taking over more tasks.
Yeah, sources predict things like generative AI and advanced orchestration could automate a significant chunk, maybe 60%, of traditional data management tasks by 2027. We'll likely see more sophisticated concepts like semantic data fabrics, computational governance, where rules are code declarative approaches, where you define the, well, not the how, more powerful low-code, no-code tools, and highly composable platforms you can adapt easily.
So the role of the data engineer changes.
Fundamentally, less time spent fixing broken pipelines, more time spent enabling strategic insights, working with the business, designing robust systems. It becomes a higher value role.
That future sounds, well, incredibly efficient. Maybe almost effortless, though I doubt it. For someone listening now, perhaps feeling a bit overwhelmed by all these tools, concepts, the sheer choice, how do they even start? How do you begin thinking about building or updating your own data stack?
Yeah, that's the million-dollar question, isn't it? And the first most critical thing to get is there's no single best modern data stack. There just isn't.
It depends.
Totally depends on your specific business needs, your team's size and skills, your budget, how complex your data sources are. What works for a startup is different from a massive enterprise.
Okay, so start with your own context.
Absolutely. And don't try to boil the ocean. Don't feel you need every single tool we mention on day one. Focus on the core components first.
The essentials.
Yeah. You definitely need reliable data storage, probably cloud-based like Snowflake or BigQuery. You need a way to get data in data ingestion. You need a way to clean it up, data transformation, likely using that ELT approach with something like dbt. And you need a way for people to see it. Business intelligence. Start there.
Get those fundamentals right.
Right. And consider your team. If you're short on engineers, maybe lean towards managed services where the provider handles more of the underlying infrastructure. If you have a strong team, maybe you have more options with open source or building blocks.
And leverage that modularity.
Exactly. That's the beauty of it. Start with core tools, then add or swap components, maybe add reverse ETL later, or a dedicated data quality tool as your needs evolve and your team grows.
What about actually implementing it? Any key practices?
Some key things mentioned in the sources. Define clear data domains and ownership early on. Think about data contracts agreements between systems on data structure and quality. Use infrastructure as code to manage your cloud environments reproducibly. And crucially, don't aim for perfection up front. Aim for evolution. Build iteratively. Get value quickly. Learn and adapt. And invest in training your people. The best stack is useless if nobody knows how to use it properly.
Excellent practical advice. Well, we have certainly covered a huge amount of ground today. We've really unpacked this dynamic world of modern data engineering in 2025. We looked at the big trends reshaping everything, identified those essential building blocks of the modern data stack, talked through the very real challenges, but also the exciting future opportunities.
Yeah, and I think the core message that really shines through from the research is clear. Data engineering.
Yeah.
It's just not a back office IT function anymore. Not at all.
Strategic now.
Absolutely. It's become a fundamental pillar for business agility, for resilience, and really for driving growth in this completely data-driven economy we're in.
So understanding this landscape, even at a high level, it feels essential for anyone making decisions today. Whether you're building a team, picking technology, or just trying to figure out how your organization can really harness the power of its data.
Definitely. Which, raises one final interesting question to perhaps leave people thinking about.
Okay.
As these data engineering tasks become more and more automated, with sophisticated tools, AI co-pilots doing more of the heavy lifting, how do organizations make sure they strike the right balance? How do they leverage all this amazing tech while also cultivating those uniquely human skills, the critical thinking, the deep business understanding, the ability to ask the right questions of the data that are needed to truly govern it wisely and derive real strategic value?
Balancing the tech with the human insight. That is a powerful thought to leave with. That's all for this deep dive.